let's look at the questions together. So name the component in A and B. So what is used to produce bricks and potteries? Pot, clay lah. Correct? When you see this straight away, I know it's clay already lah. So the one that important Sarah, and ceramic and glass. What's the difference between these two? Anyone? Duralumin is used to do what? Can you explain why is that alloy is stronger than pure metal? Let's say it's 3 marks question. Huh? You can say the pure metal is made from pure metal atom, which is orderly arranged. So they easily slide over each other when force is exerted. Yeah. And then in alloy, atom will disrupt the dislocation of pure metal atom layers. That's how you say. You have to mention pure metal. They are made from pure metal atoms and they are orderly arranged. So they easily slide over each other when there's a force exerting them. In alloy, the different size of foreign atom, they will stop because there's all of a sudden there's a big size here. They will stop the slipping of pure metal atom lah. You can say disrupt the dislocation of pure metal atoms. Okay, now let's look at this question. How to do this? So what is the difference between, what is the basic property of A and B? They can withstand high temperature. Right? Other than that, what is saponification? It's a process of producing soap. So how to mix hydrolysis of fat? Very good. Okay, when you talk about hydrolysis, you have to add on something, alkaline hydrolysis of fat, because you need to add alkaline. Okay, is you measure 50 cm cube of 0.5 or 0.1 sodium hydroxide. Then you add 50 cm cube of vegetable oil. Okay, and then you stir the mixture, you heat them, you add sodium chloride. Like that, 4 sentences already. So what is the purpose of adding sodium chloride? Anyone? Why we need to add sodium chloride? Kalau tak ada sodium chloride, the solution will become detergent. No lah, detergent. Solution. Kita nak buat satu sabun lah. Sabun itu kan solid, satu ketul lah. So we have to reduce the solubility of soap, sabun. Very popular question. What is the function of adding sodium chloride? Reduce the solubility of soap.
Solubility.
Ketelarutan. Kita tak nak sabun itu terlarut dalam air. Kita nak dia keluar daripada air menjadi satu pepecah macam sabun. Faham? Reduce the solubility of soap. Okay, now you have to memorize the essay, So you see, measure. First sentence, you have to say measure. Okay, normally I'll ask my students to just measure first verb or first word that you write when the question is asking for describe a laboratory experiment. Okay, now you have to add in apparatus and material. When the question asks for experiment question, so apparatus will be what? Beaker, measuring cylinder, any lah, okay? So these two lah, okay? And then material material will be 0.5 molarity of sodium chloride. Sodium hydroxide, okay? It's alkaline hydrolysis of vegetable oil. You need a sodium hydroxide or potassium hydroxide, either one. Potassium is softer. The soap that you produce will be softer. Okay, material is bahan. Apparatus is bekas. What is peralatan? Okay, now, so you have sodium hydroxide, you have vegetable oil, sodium chloride. Okay, then you start with procedure. Or before that, vegetable oil, sodium chloride, Oh, please do not write symbol lah. I'm so sorry. You have to write in full. Okay? So to be safe, you can just write sodium chloride NaCl. Actually, we just see the word sodium chloride. We want to see words, no formula. Unless the question says formula. State the name the formula, then you can write formula. Okay, then after this apparatus and material, what is the next step? Drawing. You have to draw. So draw lah. Simply lah. Okay. Bunsen burner cannot be hanging. Means you must roughly need a table supporting everything. Label everything. When you draw liquid, you must have dot. I guess everybody knows that. Okay, then you just add, label here, vegetable oil plus with sodium hydroxide. Okay, and then put some here, sodium chloride. Then this one is stirrer. And then it's in Bunsen burner whatsoever. Have to label. The labeling will help you to get some points when you forgot to add in your beaker or your apparatus and material. Okay? And then the labeling cannot be crossing, means you cannot cross here, cannot cross there. Okay, your labeling must be directly straight. You know what I'm talking? Okay, haven't finished yet. Once you once you did all this thing, you have to draw a table. Then depends what you are talking about lah. If let's say, or in here you say there is nothing to relationship, or there is nothing to observe. Now what I mean, there's nothing to compare. So this experiment, there is no table. So if you want, you can add on time taken. Time taken, maybe 5 seconds, 10 seconds. So the mass of soap, maybe 5 seconds, 5 gram, 10 gram, whatsoever lah. But here you have to say lah, the mass of soap is collected and recorded in table. If you want to draw such table lah. You know what I'm talking, guys? I'm just explaining how you want to write a 12 marks or 10 marks experiment question in your paper 2, section C or section B. Understand?
Yeah.
Okay, so yes, measure and pour 10 cm cube or 50 cm cube also can, or 10 cm cube also can. Normally standardized 50 cm cube 0.5 molarity. 5 is considered concentrated. Oh, sorry, in this case, you need a concentrated sodium hydroxide for saponification. So it's measure 15 cm cube of 5 molarity of sodium hydroxide into a beaker. And then second sentence, add 20 cm cube or 50 cm cube of vegetable. Okay, 20 cm cube 20 cm cube of vegetable oil into the beaker. Next sentence, stir the mixture. Stir the mixture alone 1 mark. Okay, and then next one, heat the mixture slowly. And then let it cool the mixture. Heat the solution or warm the solution to ensure all the vegetable oil and sodium hydroxide dissolve. Okay, and then next one, cool the mixture to the room temperature. Add a spatula of sodium chloride. Understand? To reduce the solubility of soap. Filter and pad the dry, blah, 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 blah. Okay, now let's move on to the next one. Okay, just now I already asked, I say, what is the difference between glass and ceramic? Actually, both also is made from what? Both are made from silicon dioxide. What is silicon dioxide? It's a macromolecule or covalent compound. Anyone? Now, Jelita. Hi, Jelita. You tell me. Silicon dioxide is a macromolecule or covalent compound? Actually, they are covalent compound, but under category of macromolecule. What is composite? What is ceramic? How come nobody is talking to me? Okay, fine. What is ceramic then? Ceramic is actually made up of silicon dioxide mainly. But there's a mixture of other stuff also lah. What is the basic property of ceramic? If you have a textbook, you can refer to your Form 4 textbook. So there's 1, 2, 3, 4, 5, 6. 6 basic property of ceramic. You can say act as a heat insulator, hard and strong. When you see hard and strong, and heat thermal resistance, can withstand high temperature lah. Our engine block is made from ceramic. Engine block. And it breaks easily. The bricks, when you fall, it will break. And they're chemically inert. Electrical insulator. Okay. Now, there are two types of ceramic. One is traditional and one is modern. Okay, what do you know about modern and what do you know about traditional ceramic? Now, traditional ceramic is made from kaolin. Okay, so what is kaolin? You have aluminum oxide, silicon dioxide, and water in it. Aluminum oxide, silicon dioxide, and water. 2, 2. Okay, that's traditional ceramic. So when you this traditional ceramic, when you add water, you produce a moldable kind of thing lah, where you can make it into pottery, bowl, bricks. Okay, now what do you mean by advanced or modern ceramic? So this one normally they will add in inorganic stuff, some minerals, carbides, nitrites, oxides. So this one is pottery, bricks. So example of advanced or modern traditional is what? Like what I said just now, your car engine or your brake lead this, cutting this, all sort of machinery stuff. Your bearing. These two enough. I write something that your textbook got. Or else when you write something your textbook don't have, your teacher will be hesitant to give you marks. Okay. You understand what I'm talking? Yes? Learn something? Now, ceramic also used in medicine, which I don't think is a very popular question. No. Okay, now let's look at composites. Now, what is composites? Composite is actually made out of 2 or more things together to make it a superior things, like superconductor. What is superconductor? What is superconductor?
A conductor that doesn't have a resistance.
Very good. They can conduct current or conduct electricity with 0 resistance. Okay, now, where can you find superconductor? In devices or anything that requires super extremely high current, like your maglev train. Train, we actually use current to produce magnetic field, electromagnetic field, correct? So the process of producing magnetic field require large current. And we do not want to have any energy loss. So we don't want to have any resistance, because when you have energy loss, you're going to have fire. You're going to catch a fire in a train. You know what I'm talking? So other than that, we have photochromic glass. We have fiberglass. It's a mixture of 2 or more different things, or sometimes we call it non-homogeneous substances. What do you mean by non-homogeneous? Non-homogeneous means they are not the same type. Heterogeneous, okay, for those who take chemistry, physics. Non-homogeneous substances. Okay, so to make a superior substances. Okay, now for example, superconductor, something that can conduct current with zero resistance. Second one, fiberglass. Fiberglass is used to make um fiberglass is used to make what helmet? Your boat. Okay, why I say we use fiberglass? What's so good about fiberglass? One is very strong and very light, very light. Okay, and then we have reinforced concrete. Okay, so fiberglass is actually made out of what? If you want to know, it's actually made from plastic and glass fiber. Plastic and glass fiber. Superconductor is made from lithium oxide, if I'm not mistaken. Okay, let me see. Double check. I forgot is photochromic glass. What do you have in photochromic glass? You have silver chloride. Because silver, when it exposed to sun, they will receive the electrons from the sun and produce silver atom. And this is the one that will cause the darken of the screen. Correct? You all learn something? Yes. Lithium barium chloride. Lithium barium copper oxide. Superconductor is made from yttrium, barium, copper oxide. YbCbCO, sorry. Yttrium, barium, copper oxide. Okay. Now, other than maglev train, also the superconductor is used in MRI. Okay, now what is the characteristics of A and B? They are talking about ceramic. As I told you, any of these six you can put in. Okay, six are chemically inert, electrical insulator, hard and strong, can withstand high temperature with thermal resistance, break easily. Another one is what? You have to memorize yourself. Electrical insulator, heat insulator, heat resistant, chemically inert, break easily. Okay, I'm memorizing. Are you guys? Okay, now let's move on to the next one. Okay, now what is the difference between these two A and B? What is B first? It's used to break these. Oh, this is actually talking about advanced and modern. Modern and traditional. See, so normally you can actually guess what they are trying to ask. So what is the difference between this? You can say what? You just say, because they never ask you what is A and B, you can say A is traditional ceramic, B is advanced ceramic. Like this, you get 1 mark already. And A is actually made from clay. B contain oxide, carbide, and nitrites. Okay. Or actually advanced ceramic, by the words also you can guess lah. Advanced means they will have a better property compared to the traditional one, which is they are more chemically inert. They has a higher resistance towards heat. They are more, they can they can conduct, they have this superconductivity property lah. Superconductor, they can conduct electricity with zero resistance, but traditional cannot. Okay, anyhow, I'll write down the answers for you. Now, what is another usage of substance A? What can clay do? What can clay do other than making pot, cooking plate, potteries, tiles? Can use to make tiles, bricks, cookware. There's a way of Chinese cooking chicken. They wrap with a clay and then they put it underground. They heat it in a soil, in a high heat. And then when you eat that time, you have to break the clay. A and B. For first state, even though they never ask you to state, but they ask you to list the difference, you can just say A is traditional ceramic. B is advanced. And then B contain nitrite, carbide, and oxide. And A contain the normal clay. And then this one is lower resistant. To heat. Will be higher resistant. To heat. But in exam, just better do this, okay? Enough. But here you additional knowledge if you want. Less chemically inert. This one will be more. Okay, last one is this one. No superconductivity property. Okay, yes, it has superconductivity. When I see this, I know it's saponification. Very good. Now, what is the name of this reaction? Yes, saponification. Tell me what is the purpose of adding sodium chloride? You don't know, I'm going to hug you and we cry together. Now, what about this? How to draw? Okay, now how actually saponification form? The H from the alcohol remove and react with this. COO. Okay, I forgot. I mean, if let's say you forgot already, then you can refer to this. You still remember? Correct? So we need to draw this. So we have 3 Na. So we need a COO. Where's the COO? Here. Okay. COO, sorry. The COO is here, correct? So it will be CH3. I mean CH2. Copy only what you see here. We need a COO, and then combine with the Na. You know what I'm talking? Kalau lah you sudah lupa macam nak do lukis. This one you still remember, right? This is actually the soap salt. Betul? When you dissolve soap in the water, they will reduce the surface tension of the water and wet the clothes. And then soap anions will produce, and the cation sodium will flow around. So the one that involved in cleaning action is the soap anions, remember? If it's talking about detergent, then the way of drawing will be OSO3 negative. Am I right? Okay, now, so I need a COO. Just now I draw like this doesn't make sense because I know the COO so will be this direction. Will be this direction, COO. Okay? Now, so combine them together. Copy this one first. COO and A. So you have 3 CO, you have 3 and A, so put a 3 here. You understand what I'm talking? Okay, okay. You tell me what is soap. Soap is actually made from vegetable oil. Made from oil. Boil water. Hydrolyze with sodium hydroxide. Alright. What is oil? Oil is ester. So what is ester? Ester is actually made from carboxylic acid and alcohol. Am I right? So oil is actually made from what? Made from fatty acid and glycerol. Correct or not? Carboxylic acid, the functional group is COOH. Alcohol, the functional group is ROH. Ester, the functional group is COO. Eh? COO here. This is C. They draw the balik, the other side. Do you know what I'm talking? That's the same line now. I mean, not the. Can you see my CO is this way? Their CO is this way. You understand? Slightly better? That's what I mean by this way and this way. Okay. Okay, now, and then this one is a very popular question. Normally, they'll ask you to draw what is the anion, the head anion. The head of anion is hydrophilic. What is hydrophilic? It dissolves in water. The tail dissolves in oil or grease. Okay, now, you know what I'm talking about? Yes, huh? Now, back to this. Okay, now. Now, back to this again. Saponification is actually reacting or mixing oil and sodium hydroxide with a little bit of heat. Huh? Okay. So what is oil? It's an ester. Ester is CO. And then react with sodium. They give you the salt. They'll give you this. What is the product? Yeah, salt and what? Okay, they'll produce the glycerol. Which is alcohol lah, betul lah saya. I see. Long time never do. So forgot. Okay, now you produce glycerol. What is glycerol? Propan 1,2,3 thiol. Correct? Glycerol is propan 1,2,3 thiol. Okay. What is propan 1,2,3 thiol? Will be 3C also got OH because 1,2,3 ma. Thiol 3 hydroxide. Okay. But see hold on. I have taken this just now to react this. Okay, and then what about this? You go where? You go here. But anyhow, you are not required to know this, okay? You just need to know they produce glycerol only. Glycerol. Okay, but wait, this CH2. Okay. They produce propan 1,2,3 thiol only lah. They won't change together. They'll produce this one. Yes. Glycerol. You understand what I'm talking? You all flip to your textbook and have a look, please. Okay, now saponification is actually hydrolysis of a vegetable oil or any oil, okay? And sodium hydroxide to produce a soap and glycerol. What is glycerol? Glycerol is actually alcohol. It's a propan 1,2,3 thiol. Okay, now hydrolysis is actually opposite meaning of condensation. Glycerol plus fatty acid give you fats, right? So fats hydrolyzed, they'll become what? They'll give you glycerol, reverse only the process. Okay, now let's move on to this one. Now calculate the mass of soap produced if 0.05 mole of soap is being produced. Okay, now how to find this? Now from the equation, I can see that there's a 3 mole of soap is being produced when I'm using 1 mole of this. What do they want? They want this. Oh, okay. Slowly lah. Just formula, plug in. and fill in the blank. 0.05. The mass, that's the one you want to find. And what is the RMM for this whole thing? Please do not take in the 3, huh? The 3 is just to balance the equation. So what is the RMM, sorry, for this whole thing? Can somebody tell me? Alia, tell me what is RMM for this? How much?
278.
Yes, 278. So multiply 0.05, how much? 13.9 gram, please. Okay, next one. A student wish to prepare potassium palmitate soap. What alkaline should be used? This one you don't know. I don't know what to say. Potassium hydroxide. Okay, now next one. What is the difference between potassium hydroxide and sodium hydroxide? I told you one is softer. Okay, what is hard water, Alia? What is hard water?
Yeah. Water that contains magnesium and calcium.
Yes, water that contains magnesium and calcium. That's hard water. Okay, let's look at this question. I think they are talking about hard water. Yeah, it is. So look at this. The stain is still here. So this is soap. Only detergent can clean the thing in any condition. Soap cannot react with hard water and also acid. No. Acid and hard water cannot. Why? Okay, now a very popular question. They ask you to explain the cleaning action. Cleaning action of soap. So first you have to say you dissolve the soap in water to produce the soap anion and cation. Okay, and then what happened? Dissolving soap reduce the surface tension. Reduce the surface tension of water. Surface tension of water. And wet the clothes. Okay, and then now you can draw. Okay, this is the soap anion. Okay, and then you draw in. This one is hydrophilic. Okay, this is hydrophobic. Okay, I know my writing is very bad because I want to be fast. Now, and then you see now the head of anion soap is hydrophilic, dissolved in water. And then the tail of anion soap is hydrophobic and dissolved in grease. And then you can draw. And then this one is grease. This is your clothes. So what will happen? Then you say, same charge. Same charge of hydrophilic charge. Sorry, hydrophilic head. Repel each other. And with the help of agitation, the grease lift up. The grease, or put a bracket, stain, lift up from the clothes and form emulsion. Okay, so the keyword you have to mention, okay, reduce the phase tension of water. Reduce the phase tension of water. And then you have a hydrophilic head dissolved in water, hydrophilic head dissolved in water, a hydrophobic tail dissolved in grease, and then agitation, and then emulsion. Okay, this is the one. And then for you must know also what is the difference between digital apa cakap? What's the difference between detergent and soap? Other than soap cannot react with hot water and acid, but detergent can react with both. Other than that, detergent is non-biodegradable because it's made from petroleum. Okay, soap is made from vegetable oils. They are biodegradable. Sebab apakah deterjen diperkenalkan? Disebabkan zaman peperangan tak cukup makan. So kan kita menghasilkan sabun daripada apa? Minyak kan? Minyak tumbuhan dengan minyak haiwan. So zaman peperangan tak cukup binatang untuk makanan. So kita come out petroleum lah. So detergent is made from petroleum. Understand ah? Okay, now look at this. Which cleaning action is more effective in hot water? Explain your answers. So they didn't say what is A and what's B. So you please write down, answer to the question first. You can say agent B is more effective. Okay, and then you can say agent B is detergent. Apa cakap agent A lah is more effective? Sorry. Agent A is more effective. Agent A is detergent. Okay, why? Oh yeah, forgot to tell you. Talking about hot water, they will ask you to explain. Okay, now why is it they cannot react with acid and hot water? Because the soap will react with them to form scum. Hydrogen ion from an acid, calcium ion and magnesium ion from the hot water to produce insoluble white precipitate, which is scum. Who is the one that react with them? The anion 8 or the anion soap. So this will reduce the concentration of anion soap for available for cleaning action. Okay, so A is the detergent. You haven't explained yet, no? You haven't explained yet why is that it can react with hot water. Because agent A do not, like how you answer your biology, make it into a negative statement. When they ask you to explain, what do you mean by negative statement? Okay, what happened to the stomach if pancreas is removed? So you already know the function of pancreas is to produce insulin ma. Then you say lah, insulin is not produced. And then you already know that insulin will help to convert excess glucose into glycogen ma. Then you say excess glucose will not convert into glycogen. That's it. So same thing as this. So how? Explain why is this more effective? Because agent A do not form scum. Everybody clear? Dengan menggunakan bahan-bahan pour 2 cm cube of hot water into 2 testing tube. Okay, I like to use this pour 2 cm cube. If you are talking about experiment which is very small, for example, if they ask you to describe the experiment of brown ring, you do the same, pour 2 cm cube. If it's the experiment is very big one, like producing soap, then you use 50 cm cube of 0.5. If it's concentrated, 50 cm cube, 5 molarity. Okay, now, how to do when the question say describe. So you have to do in very detailed form. Pour 2 cm of hot water into 2 test tubes. Then add 2 cm cube of what do you want? Describe the differentiation between soap and detergent. And you know, okay, and then pour 2 cm of soap water and detergent into each. separately into each test tube for respectively lah. Okay, and then shake. Or the one you stir the mixture. When you add something already, the next step you have to say stir. After that, then you say, oh, insoluble precipitate or scum is observed in the test tube with detergent. Like detergent bowl with soap. You know what I'm talking about? What there's no precipitation observed in the test tube with detergent. That's how you write when the question asks for describe. What about gas test? So you have to describe, meaning observation. What's the test? What's the result? Observation means, okay, let's say I want to talk about hydrogen gas. Collect the colorless gas into a test tube. Place, what is the test? Place the lighter wooden splinter near the mouth of test tube. Next one, a pop sound is heard. You know what I'm talking? For example, like this case, I change it into browning test. You can say, oh, pour 2 cm cube of dilute sulfuric acid into test tube. Add 2 cm cube of ferrous sulfate solution into a test tube. Shake the mixture. A few drops of concentrated sulfuric a few drops of concentrated sulfuric acid is added in the test tube. A browning is observed. Okay, now let's look at this. What's the information you can see? From here, I know it's the exothermic reaction. How much energy is being produced? 728. You can say 728 kilojoule of heat is released when 1 mole of ethanol is completely burned in excess of oxygen to produce 1 mole of carbon dioxide and 2 mole of water. That's how you write. I repeat. 0.28 kilojoule of heat energy is released when 1 mole. This one is actually asking for definition. Still, remember what's the definition of heat of combustion? Amount of heat released when 1 mole of substance is completely burned in excess oxygen. 1 mole of alcohol, 1 mole of substance, okay? Heat of combustion. What about heat of neutralization? 1 mole of water is formed. When 1 mole of water is formed from one mole of hydrogen ion and 1 mole of hydroxide ions, okay? So this why I know how to answer questions because this one they're asking for definition. Okay, 728 kilojoule of heat energy is released when 1 mole of what is this? Methanol, right? Okay, if you scared, and then just put a bracket methanol is burned. It's completely burned in excess. You have to say excess oxygen. Okay, to produce carbon dioxide and water. Okay, you want to say 1 mole of carbon dioxide and water also can 2 more because the one that I want to specify is this one because according to definition, it's when 1 mole of substance is completely reacted. Burn in excess of oxygen. If it's a heat of precipitate, when 1 mole of precipitate is formed. Heat of neutralization, when 1 mole of water is formed. Heat of displacement, when 1 mole of metal is displaced from its aqueous salt solution. Refer back to your textbook, okay? Now, let's look at this again. Okay, how to produce? H equals to MC theta, right? So, what is the M? How much water is being used? 200. So, what is the C? 420, right? Oh, okay. They didn't give us the temperature change, meaning cannot use this formula. Then we use this one, since we already tell us when 1 mole of methanol produced, they produce 728. 1 mole. So sekarang berapa mole? How many mole of methanol we are actually using? Count. So methanol, how much use? Tell me. This one no temperature given, so you can't do this. So you have to use this. Since this one is given. This is called heat of reaction. It's all talking about per mole 1 mole. Okay. This is methanol lah. CnH2n plus 1 OH. General formula for alcohol. So meat is 1C. For those who already forgot. So be 12 plus 4 plus 16. You should get 0.05 mole. Okay, and then you can use NISBA to do. 1 mole of methanol produce how much? 728 kilojoule. 728 kilojoule. 0.05 mole produce, I don't know. So, kilojoule lah. You cross multiply, solve this ratio, you should get your answer. Kilojoule. How much? Got already, 36.4 kilojoule. Correct? Okay, now they want to find the temperature change. Okay, just now we do this halfway, right? And then we stuck because there's no temperature given. So now they're asking for temperature change. Okay, again, this formula. And fill in the blank. What is the H? We already got, which is 36.4 times 10 power 3. Why times 10 power 3? Kilo ma. Okay, and then M, how much water? 200. Okay, make sure this is 4.2. Okay, this one I say 420. 4.2. Okay, what's the temperature change? That's the one you want to find. Solve this algebraic math and you get the answer. 3.3, yes. $43.3. Okay, now what about this? They say the real value that you got is actually very big difference from the value that you calculated. Why? Always ask why? Because there's heat loss to the surrounding, correct? Because during the experiment, the burning of methanol, the heat might loss due to wind. Okay, the heat produced might be absorbed by the retort stand. Correct? By right, we should be by right, the heat of the combustion should be 100% absorbed by the water. So they say what is that? Langkah bercakap or precaution step. Windshield law. Like what I said, because the heat of combustion might be lost to the surrounding due to wind. By right, it should be directly supplied to the water. So use windshield, or like what I said just now, part of the heat might be absorbed by the retort stand or wire gauze. Never use wire gauze. I no need lah. Okay, this one enough. Okay, now next one. Okay, now the keyword is you have to say number of carbon per unit molecule or carbon percentage. This one, they always like to ask siapa yang tak boleh buat and then it come out exactly the same please beli 20 keping. How to get the 3 marks? One, you have to say the number of carbon per unit molecule. Second, more carbon dioxide water is produced. Next will be more heat is produced. Okay, I'm going to write, don't worry. Number of carbon atom must be exactly the same per unit molecule or per molecule. This one is talking about butanol, so butanol is higher. Okay, and then more carbon dioxide and water is produced. Then more heat is released. So popular question. What is the oxide found in kaolin? Anyone? Okay, now what is found in your kaolin? Somebody? Aluminum oxide and silicon dioxide, right? Aluminum oxide and silicon dioxide. Kan tadi sudah cakap. It's made from aluminum oxide, silicon dioxide, 2 water. Okay, but anyhow, the question is asking for what is the oxide name. So you shouldn't like this. You should name. No formula. Aluminum oxide, Aluminium is not a transition element, so you no need to write 3. Just say aluminum oxide. Okay, and then silicon is not a transition element, so no need to write 4. Just write silicon dioxide. Do you know what I'm talking, guys? Don't tangan gatal and write this. Don't. Wrong. Only transition element you need to label their oxidation number.